Welcome back. It's now time to discuss while loops. In general, loops allow us to repeat code multiple times. The first basic loop that we're going to discuss is the while loop, which will continually execute a block of code while a condition remains true. Let's see an example of this syntax. Here we can see we've defined a variable x equal to 1, and we say while x is less than or equal to 3, we have a block of code that will continually execute while the while condition remains true. We will go ahead and print out the number x, and then we see here in commented form that we're adding 1 to the x variable. So we reassign x equal to the previous value of x plus 1. So as we continually run this loop, we start off with x being equal to 1, so we print it, and then we add on 1 plus 1, so now x is equal to 2. Then 2 is still less than or equal to 3, so we go ahead and print out 2. Then we say 2 plus 1 is equal to 3, 3 is still equal to 3, so it's technically less than or equal to 3, so we print out 3. Once we have 3 plus 1 is equal to 4, the while condition is no longer true because 4 is not less than or equal to 3, so the while loop terminates. As a quick note, be very careful of while loops because if a condition is set to always be true, then your while loop will actually run forever, causing your program to get stuck. Let's explore while loops in a little more detail with Python. Let's begin by coding out a similar example to what we just discussed. We will say x is equal to 0, and then while x is less than 3, we'll execute some code. We will say print x is currently, and then we will actually print the value of x. Notice here I'm printing the actual variable x, not the string x, so keep that in mind. And then we're going to print still less than 3, add 1 to x, and then we'll actually do that here. We'll say x is equal to x plus 1. And then once we've done that, we will print a new line using our special escape character n. Then when we run this, let's see what happens. We get x is currently 0, still less than 3, add 1 to x. It's 1, still less than 3, add 1 to x. X is currently 2, still less than 3, add 1 to x. And notice, right after we print this, we end up adding 2 plus 1 to set x is equal to 3. And since 3 is not less than 3, it's equal to it, we actually then terminate this while loop. Now if we set x less than or equal to 3 and we run this, you'll notice that we actually end up running one more time because 3 is equal to 3 is still valid for this while loop to continue running. Now as a quick note, it's very easy to accidentally set a condition to always be true. So let's say we just said while true, and this is very dangerous to do because basically there's nothing to kill this while loop. We will say print still true, and we're going to eliminate this code and eliminate this code. So this is something you do not want to actually execute because it's going to constantly be printing still true, pretty much forever. So when we run this, you can see I have an asterisk here, and your computer may even slow down if you actually run this, and you'll see still true is constantly being printed out. In order to kill this procedure, what you need to do is either do Control plus C if you're running this .py script at your command line, or you can come up here in the notebook to kernel and then hit interrupt, and it should interrupt your kernel. You'll notice it no longer has that asterisk indicating that it's no longer running, and if you scroll all the way down, you should see something saying keyboard interrupt. So to restart the kernel, click restart and click that. We'll go ahead and delete this, do Shift Enter, and now we're back and ready to go. So let's move on to another probably more realistic example of when you may want to use a while loop. So in order to do this, we first need to show you how you can accept input from a user. So in order to accept user input, you use the input function. So we have input, notice it's a special keyword since it's being highlighted, and then you pass in a string, and this is the string that will appear to the user. So we can say please input a number, and then a space there. Do Shift Enter, and you'll notice you say please input a number, and you have this little box show up. If you're running a .py script, it'll still have the string print out, but you won't see a little box. It'll basically just be waiting for you at the command line for you to insert something. So let's provide a number, 2, hit enter, and you can see the output is the string 2. So input is actually returning this string version of whatever you inputted. So we can then say saved underscore input is equal to input. And then when I run this, I can input the number 2. And then now, later on, I have access to this variable, saved input, as the string 2. So let's show you a little more practical application of using a while loop. We'll create a little program here in this cell. It says welcome agent, and we'll create a passcode variable to be equal to 0. So that's some sort of default passcode that we've already defined. And we're going to say while passcode is not equal to, remember that's exclamation point equal sign, 1, 2, 3, colon, we're going to say passcode is equal to the integer cast or transformation of please provide your passcode. So let's see what we're actually doing here. I'm going to print welcome agent. I set a default passcode, and then while the passcode is not equal to 1, 2, 3, I will basically be continually asking for a passcode to be provided. So I'm going to keep asking for the correct passcode. So let's run this and see what happens. It says, please provide your passcode, and due to the formatting of me in this notebook, you can see that the input is actually above that welcome message, but you can ignore that for now. It says, please provide your passcode. Let's provide a wrong password, 234. Hit enter and see what happens. And notice here, now it asks again, please provide your passcode. We can provide another one by accident, something like this, 354, etc. And it's going to keep asking us until we finally provide 1, 2, 3, and then the code is done executing. That while loop, that condition, is no longer true because 1, 2, 3 is equal to 1, 2, 3. Notice here what I'm doing with int is I'm essentially transforming the string input of 1, 2, 3 into an integer. That way I can make the comparison here. Because technically, when I do input, let's show you an example here, and I provide a number, 1, 2, 3, the output is actually a string of that number. So if I have 1, 2, 3, that's different than the number 1, 2, 3. This is a string 1, 2, 3. This is the integer 1, 2, 3. So if I check for equality here, it's going to say false, they're not equal because of different data types here. One is a string, one is an integer. If I wanted to transform this into an integer, I can use int and then pass it inside. Similarly, I can actually do the opposite. I could say str to transform this one into a string, and then check for equality with 1, 2, 3. And the way you can find out what are these special codes to pass in, int for integer or str for string, you'll notice that they actually match up with the result of type. So if I say type 1, 2, 3, it returns back str, indicating that's a string, but that's also the same built-in function to try to transform variables into strings. Or if I try to say type of the integer 1, 2, 3, it gives back int. So it's a nice little connection between types and they're also their built-in function that attempt to transform other types. And knowing what we already know about control flow, we could actually expand on this simple example here and add in some more control flow to ask for or indicate that the passcode was wrong. So we can also say if passcode is not equal to 1, 2, 3, colon, and note the various levels of indentation I have now. I'm going to say print wrong password, print please go again, and then I will print a new line using that special \character n. And then after all this while loop, notice my indentation, I'm going to print correct password. So note here how important indentation is to organizing your code. Everything here is inside this while loop because it's indented past this while loop, indicated by this colon here. And then everything here is inside this if statement because it's indented into this if statement. And then finally, this print correct password is only going to execute once this entire while loop is done executing because it's outside of this while loop because it's not indented. So notice the indentation here and make sure your code matches the same indentation I'm showing here on the screen. So if we run this now and we're providing wrong passwords, such as 345, it's going to say, please provide your passcode, wrong password, please go again. And this is a way you can continually ask for user input until they happen to provide you with the right password, 123, and then it says correct password at the end. Finally, I want to mention one more keyword, and that's the break keyword. Break keyword allows you to actually break out of the loop that contains the break keyword. So I will show you a simple example of this. I'm going to set x is equal to 0 and say while x is less than 10, colon, enter, print x, and then say x is equal to x plus 1. And if I just run this, notice I will get back 0 all the way up to 9, because once x is equal to 10, this while loop terminates. But if I wanted to break out of this while loop prematurely, I could say if on some condition, such as x is equal to 3, and then I can say break. And that's going to break out of the top containing loop. So now when I run this, notice here, since x is equal to 3 here, we immediately break, and that breaks out of this loop. We'll go ahead and explore this break keyword later on, but I just want you to be aware of it for now. Okay, that's it for while loops. Coming up next, we're going to discuss for loops. I'll see you there.